Okay, section 1.2 functions, page 16. This is another section that is kind of a review at the beginning, and then we get into some new stuff. So, the top of page 16, we know two quantities can be related to each other by some rule, and that is called a relation. But when relations have every element of x matched up to one element of y, then it's called a function. So ordered pairs like 3, 7, 4, 8, 5, 9, 6, 10. This relation is also a function because every x is going to a unique y. However, if I add this other point, then this relation is no longer a function because this x, this 3, has two different y values. So think of functions in terms of business. In order for a function, which is just a rule, to be beneficial to someone in business, you need to know that when I input a value, then it gives me a specific output. It would be very frustrating to a business person if they input 3 and sometimes they got 7 and sometimes they got 4. That would not work. So you need to know that when I put in a specific value, I get out a specific value. Now so that's why that ordered pair can't be a part of this. But this ordered pair, oops, not a 4. This ordered pair is just fine. Even though they both gave us an output of 8, that's okay. Because when I put in a specific number 4, I got the output of 8. And when I put in a specific number of 7, I got the output of 8. That's okay. One of the easiest ways to tell if a relation is a function is to use the vertical line test. Sometimes it's confusing looking at these points. Like, which one of them can't be the same? Is it the x's that can't be the same or the y's that can't be the same? So rather than trying to memorize these rules, sometimes it's just easier to think about them on a graph. If we were to plot these points, would they pass the vertical line test? Well, let's just real quickly plot them. Like 3, 7, 4, 8. I'm saying real quickly. 5, 9, 6, 10. Oh, so far we're passing the vertical line test. Vertical line test, if you remember, just says if I were to take this vertical line up and down and slide it anywhere across the graph. So let's say I took that vertical line and I put it right here. Is it only going through one point? Yep. No matter where I move it, it's only hitting one point on this graph. That means it passes the vertical line test, or it's a function. But what if we put in this point here? I think it'd be about right here. Well, why does this point get marked out? What was wrong with it? Well, if we slid the vertical line right there, it fails the vertical line test because that vertical line is going through 2 points. So that's just a real quick test for functions. But what happens with this point here, 7, 8? Be somewhere around here. I don't know where 8 was. Somewhere around here. 7, 8. That's okay. It's not on the same line as the 6. There's nothing else on the same line as the 7. It's just fine. I might have made that more confusing than it needed to be. Please ask me about it if you need to. So we have a lot of terminology that's important with functions. We have the x value and the y value. The x is sometimes called the input. Y is sometimes called the output. X is the independent variable. Y is the dependent variable. X gives you the domain values. Y gives you the range values. Just a real quick note for this independent and dependent, how to keep those straight. If you picture X as being a little person and he's got little feet here, X is independent because he can stand on his own 2 feet. Ask me about this tomorrow and I'll demonstrate. Y is not independent because he's only got 1 foot and he might topple over. But X has a firm foundation and he can stand on his own 2 feet. And finally, that's going to bring us to this idea of function notation. You did this in Algebra 2. We might take it a little further, but instead of saying y equals 3x plus 2, we can use function notation and write f of x equals 3x plus 2. So instead of y, we replace it with f of x. So now instead of talking about a line, we're now talking about a function. This function is a line. I suppose instead of saying line, I would rather say equation. So it's not a linear equation anymore, it's a linear function. And function notation is great. So let's say we wanted to evaluate the function at x equals 5. That just means every x in our function gets replaced with 5. So f of 5 is equal to 3 times 5 plus 2. And that's all function notation is. You just substitute in the function's value. So order of operations, 3 times 5 is 15, and 15 plus 2 is 17. So function notation is a really handy and quick way to write and evaluate equations.